So after studying the Zener diode and its applications and the PN junction diode basics, now let us see the applications of PN junction diode, that is in rectifiers. Okay, so what is a rectifier? A rectifier is a device which converts AC into pulsating DC. Okay, so this is the output of rectifiers we have got. This is not exactly DC. It is called as pulsating DC. So the applications, the definition of rectifier is it is a device, it is a circuit which converts AC signal into a pulsating DC signal. So in rectifiers we have mainly two types. One is half wave rectifier, one more is full wave rectifier. But in full wave rectifier itself, we have two circuits. One is full wave rectifier, one more is full wave bridge rectifier. But the output is same. But in the components, whatever we use in the designing for a full wave and bridge wave rectifier makes the difference in the circuits. So in overall, it is three types. One is half wave rectifier, full wave rectifier, one more is full wave bridge rectifier. Okay, so rectifiers convert an AC voltage into a pulsating DC, and the process is called rectification and the circuit is called rectifier. Okay, so two types, half wave rectifier. This is the circuit of half wave rectifier wherein we use only one diode. How many number of diodes are used in half wave rectifier? There is only one diode. Okay, and here you are going to apply the input voltage. Okay, this is the AC input voltage whatever we apply to the diode, and here we measure the output voltage. This is the output voltage. And what is the input we are giving? We are giving the input as AC signal. So that is it will have both positive half cycle as well as the negative half cycle. So when you analyze the circuit of half wave rectifier, now we are going to analyze it for both the cycles. So now let us take from the interval 0 to t by 2. What is that 0 to t by 2? It is during the positive half cycle of the input voltage. So for the positive half cycle of the input AC voltage, diode is forward biased because this is positive, anode is positive and this will be negative. So diode is forward biased and acts as a short circuit, correct? Hence the current flows through the circuit. So V0, what is the output voltage V0 we are going to get? V0 will be equal to the current into the resistor. If I take the current as IL, so V0 will be equal to IL into, if I take this as RL, load resistor, V0 will be equal to IL into RL. So this is the case when the diode, during the positive half cycle of the input voltage. So we get the output voltage which is equal to I0 into IL into RL, which is same as input. So during the positive half cycle of this complete explains during the positive half cycle of the input voltage. So during the positive half cycle of the input voltage, what happens? The output is same as input. From 0 to t by 2, we get same as input voltage. Voltage whatever that is being applied at the input. And now what happens from t by 2 to t? What is from t by 2 to t? That is during the negative half cycle of the input voltage. Diode is reverse biased. So this will be negative because the input is negative. This will be positive compared to the input. This will be at positive voltage. So what happens? Diode is reverse biased. So when the diode is reverse biased, it acts as open circuit. So there is no path for the current to flow. So what is current? Current will be equal to what? IL will be equal to what? 0 volts. So what is V0? V0 is IL into RL. If IL is 0, V0 will be also equal to 0 volts. Okay. So in half wave rectifier, current flows only in the positive half cycle of the input voltage. During the negative half cycle, current is 0. So if you are giving this voltage at the input, what is the output we are going to get? We get output only during the positive half cycle. Negative half cycle, it is 0. Negative half cycle, it is 0. So we get only one half cycle of the input voltage at the output of the half wave rectifier. So this is the output of half wave rectifier as I've explained. For this is the input, and this is the output. So the process of removing one half of the input signal is nothing but your half wave rectifier. So, okay. So what is V0? How do you define V0 of an half wave rectifier? V0 will be equal to Vm sin omega t. Vm sin omega t is what? the input whatever we are applying, the AC input, V naught is equal to Vm sin omega t only from 0 to t by 2. T from 0 to t by 2. From t by 2 to t, what is your output? Output is 0. From t by 2 to t, output is 0 volts. So this is 0. For the negative half cycle, output is 0 and you are getting output only in the positive half cycle of the input voltage. So the advantages of half wave rectifier is it is simple, only one diode. Components are not much components are required. So only one diode, circuit is going to be very simple. But the disadvantages are this is not a perfect circuit to convert an AC into DC signal. Correct. Because the ripple components are more and we are not getting the exact DC. So the efficiency of the half wave rectifier you are going to get around 40%, which is even less than 50%. So this is not an effective circuit to convert an AC signal into a DC signal. Also the ripple factor will be more here. So we have the next circuit. In order to improve the efficiency of the rectification, we have the next circuit that is called as full wave rectifier. Working of bridge rectifier. So again, similar way, we are going to analyze the circuit for both positive and negative half cycle of the input voltage. So during the positive half cycle of the input voltage, so this is positive. This is at positive voltage and this is at negative voltage. So when you give positive here and negative here, what happens? This diode and this diodes are forward biased and the other two diodes are reverse biased. So current flow is like this blue color line I have shown, no? From the positive and 2 through this diode, through the load resistor and like this. This is during the positive half cycle and you get the same positive half cycle as output. During the negative half cycle, again the other two diodes are forward biased and these two diodes are reverse biased and the current flow is like this. So again we get the same positive half cycle as output even for the negative half cycle because the current flow through the load resistor is in the same direction. Okay, so this is the waveform of bridge wave rectifier, which is same as full wave rectifier. As I said, it is same. It is same except the design, So the waveform for both full wave bridge rectifier and this is a circuit of full wave rectifier, in which we have used the center tap transformer. A step down transformer is used here. If in step down means it step downs the voltage. Okay, because we cannot connect diodes into the power supply directly. We should have a transformer which downs the our input voltage, that is from 230 volts AC mains, into a suitable voltage that can be given to a diode. So it is a step down transformer, but it is a center tap transformer. So here when we compare this to half wave rectifier, here we are going to use two diodes. One is D1, one more is D2, and this is where you connect the load resistor RL, and this is RL. Okay, so this is the circuit of center tapped transformer. Circuit of full wave rectifier using center tap transformer. Okay, and now how this circuit works? See, during the positive half cycle of the input voltage, what happens? Diode D1 is forward biased, but D2 is reverse biased. D1 is forward biased and D2 is reverse biased. So the current flows through the diode D1 to the load resistor in the upper half of the secondary winding. This is the cycle of the diode. I mean, this is the current how it flows. This is this path. So it flows through the diode, through the load resistor RL in the upper half of the secondary winding. So we get the waveform like this. For the positive half cycle of the input voltage across the load resistor, we are going to get the same positive half cycle as the output. During the negative half cycle of the input voltage, what happens? Diode D2 is forward biased. D1 is reverse biased. So it is open circuit here. And this is the path how the current flows. Okay. And during both during the positive and negative half cycle of the input voltage, the current flow through the load resistor is in this direction. So even for the negative half cycle, you get the output like this. So for one complete cycle of AC input voltage, we get two positive half cycle of the output voltage. So hence we tell the output frequency of the full wave rectifier is 2Fin. Fin is what? Fin is the input signal frequency. Okay, we get 2 positive half cycles. So output frequency of a full wave rectifier is 2 times of input frequency. So this is the waveform of a full wave rectifier with center tap transformer. So advantages is, of course, efficiency of the center tap full wave rectifiers are improved compared to half wave rectifier. But the disadvantages, it requires 4 diodes. Also, it requires a center tap transformer, which is costlier. Okay. So these are the 3 types of rectifiers we have. And when we compare the 3 types of rectifiers, you can compare with the number of diodes we use, the efficiency, also with the ripple factor, and this table will give you the comparison of all the 3 types of rectifiers. Okay, thank you.